I'm going to speak to you on future energy mix for developing or emerging economies. And Mauritius is just tapped as an example. And I'll take you through the general change in energy scenarios and some of the key concepts actually that have been applied in this research. Let me hasten to say that this is an ongoing research. I went to the field in October, so it's just a month that I had in between to prepare this presentation and to do a little bit of some analysis, just to share with you some of the key findings that I have found, though there's further analysis that actually is ongoing. That's basically the presentation outline, which I have, which key to it is just to map or show the energy landscape for Mauritius. I'm sure you would agree with me that there is a dramatic change in world energy scenario. From a historical, not too historical, but around about mid-70s, where you find the oil crisis, which has precipitated the global economic slowdown. And juxtaposed to this, as you move with the time, actually there's been a general trend in demographic growth, a well-known phenomenon, and the previous actually presentation or comments actually were elucidating to the issue of high population growth in Rwanda. And of course, Mauritius is not an exception, despite the fact that it's an island. And one of the key trends actually that I've noticed is actually where the developed world, which used to be leading oil importers and consumers, is actually the reverse. Emerging economies and the developing world actually are the leading oil and energy importers. And we have high demand of energy actually in the developing world and the emerging economies more than actually you find in the developed world. And actually, according to the OECD statistics, actually, it has gone up to over 60% compared to what we used to have actually in the past. And small developing islands and emerging nations are actually shaping the energy markets. The high demand actually has got bearing on the technology that is actually required actually to generate the energy. They are the consumers of the energy, and the utility of different energy options that we have, be it fossil or renewable, actually to meet the energy demand are actually envisaged in the developing world. Suffice to say, climate change is also influencing the energy policies. And the energy supply, I'm sure you would agree with me that it's a crucial success factor for development. Imagine a country without energy. How can you have development? Right. And the past decades, we actually seen the surge in renewable energy technologies and a growth in energy demand across Africa, across the world, in particular the emerging economies and the developing world. There are quite a number of key terms that actually used or actually applied in this study, which is firstly systems thinking, a structured way of analyzing complex interrelationships that are problematic. From a face value, they might seem simple, but actually very complex. And there are factors that are problematic situations, and they are independent with a causal relationship. And this causal relationship is actually a two-way. And this methodology is strong in understanding observed phenomenon, establishing the consequences that you actually envisage in the different options that are available. One other key term is actually systems dynamics, which is a way of providing means of capturing complex relationships grounded in control theory and model of non-linear dynamics. And systems dynamics is a framework for modeling and simulating that can be used to understand the complex adaptive processes operating as a tool of experimentation of scenarios and policies. Jump to geospatial technologies, which has got an array of different tools that are actually applied. one of which is remote sensing, which involves the process of acquiring information about the Earth's physical properties and chemical and biological systems. I won't bog down to how it operates. Juxtaposed to it is the notion of GIS, which deals with data, its position through coordinate systems, and the attributes and spatial interrelationships that you actually get. You'll get more when I explain some of the examples that I've actually shown. Part of this study is actually to apply spatial systems dynamics modeling as an alternative energy source. In this particular case, which is biomass, which you find occurring in space and time. This approach interfaces the spatial complexity in biomass production and social technical complexity in biofuel production and distribution. Now linked to the aspect of GIS, which deals with data, its position, and attributes of spatial interrelationships with each other, systems dynamics, therefore, is used to understand problems that are dynamic involving the notion of feedbacks. One key other word is cogeneration, which is a simultaneous generation of two different forms of useful forms of energy from using one single primary energy source. It can either be used to generate electricity or to generate heat. The problem actually is the current global energy systems, which have proven to be unsustainable both because of climate change impacts and the over-reliance on declining stocks of fuels. In addition to this is actually the over-increasing prices of oil, of fuel in the world. And there's actually been a general trend of inability to screen bioenergy options based on technical feasibility, economic and financial viability, and social environmental acceptance. And the high level of uncertainty with emphasis on techno-economic feasibility alone, which does not guarantee acceptance and subsequent sustainability of different technology options. The overall objective of this study actually has been to map and provide an analysis of Mauritius' energy security landscape. One aspect would be to develop a model based on systems dynamics and spatial analysis to test the implications of investing in energy mix, test the applicability of SNAP on Mauritius' energy scenario. SNAP is it's a model that has actually been developed by the Center for Energy at the University of Western Cape, which actually tries to look at the different energy options which a country might have, and then you can build scenarios based on the model. And key to this study actually is also to determine the potential threshold of biogas or biomass as an alternative energy source for Mauritius. And of course, draw key challenges faced by this island. I won't go to dwell on the hypothesis, save for time. Mauritius, an island in the Indian Ocean, population of about approximately 1.3 million, with an area of around 2,040 square kilometers. What's unique about this country is cogeneration, particularly when you're looking at the energy sector. And major economic drivers, tourism, and of course sugarcane production. And sugarcane production actually has been the leading economic drive for the GDP of Mauritius for the past several years. But however, recently, I think about 3 years back, it's now tourism which is taking the toll more than sugarcane production, given the decline in prices of sugar, and not emphasis actually is being placed anymore on sugarcane production, but on tourism. The research methods involves, of course, geospatial technologies, the SNAP model that I mentioned, and there's spatial systems dynamics. Save for time, I won't explain how this works. But here's a causal loop diagram and a stock and flow diagram, just to illustrate to you how the causal loop, the cause effect, concept actually works and helps us to understand and digress programs that are complex or which we actually have. I'll take, for instance, what is that? What is this? Yes, the pointer? Okay. Okay, I'll take, for instance, the... Okay, let me get close to the diagram. Land allocation for biofuel production. Suppose we have land that has actually been allocated for biofuel. In this regard, this is land for, say, sugarcane production. And the more the land we have, the more the bioresource that we actually have. And then if this bioresource is actually to be used to supply for energy generation, that reduces the gap between the actual desired amount of biomass that we need versus the bioresource that we have. And of course, it's got an effect on the land that you actually have. So supposedly, if this land is actually earmarked for biofuel production or for biomass, there are obviously some other competing priorities that you can actually have for the very same piece of land, which can actually be industrial or be it urban development, not necessarily for sugarcane production. So the policy on land actually has got a bearing on the land that you actually have for the production of biomass, which is an input for energy generation in form of biogas. Right. The more the bioresources you have, the more the biofuel production, the more the biofuel supply you can have. And of course, it's got an inherent link to the gap between the desired and actual bioresource that we have. Biofuel production obviously has got a bearing on employment, quality of life, social acceptance, energy use profile, and biofuel demand. The more we have more people employed in this sector, the more the demand actually that we have for biofuel production, because it's known to be a technology that is actually applied to provide employment opportunities. Right. This is just a stock and flow, just to illustrate the stock and flow between the land resource suitable for agriculture and the investment required in the biocomposite material. It's just an example just to illustrate. Just to show you some of the key findings. Mauritius energy landscape actually has got, it's mainly, its energy sector relies on imported fuel. 80% of its energy is derived from mainly coal, which is imported from South Africa, and also India, where they get some actual petroleum products. And of course, this has got a risk of geopolitical and economic crisis. If things don't go well in South Africa, imagine the Marikana crisis, and then we are actually expecting to export coal to Mauritius, and the country actually lives or relies on the coal. The risks are just too much. And it's expensive, obviously. It's different from South Africa utilizing its core resources, which it has. Unfortunately, Mauritius doesn't have the privilege of having the resources actually for energy generation, particularly when it comes to fossil fuels. Major players in this sector involve the Central Electricity Board, which contributes about 40% of the total national electricity requirement, and also the independent power plants, which supply about 60% of total national electricity requirement. If I'm to compare it with South Africa, you think of energy, you think of electricity, Eskom comes to mind. For Mauritius, it's actually 60% the private, which supply electricity to the grid, and 40% is actually generated by Central Electricity Board, which is a government-owned entity. The unique aspect of the energy generation is actually cogeneration plants, which actually use both coal and bagasse. Bagasse, that's received from the residue of sugarcane. So the very same plant which produces electricity for the nation produces electricity using both coal and sugarcane. So during the crop season, they use the bagasse. Off crop season, they use coal. Sources of energy in this country, it's mainly oil, bagasse, and coal, but coal is the dominant one. So that shows that the country is still heavily utilizing fossil fuels. Here's just a schematic representation of the energy generation, which you have a sugar cane. They produce sugar from the sugar cane. The very same byproduct that we get actually, which is the bagasse, is actually used for coal generation, and the coal generation produces electricity and steam, and the steam is actually used for not the steam. The electricity is actually used for bioethanol distillery, which is actually used for biofuel production. So you have electricity being produced from the sugar, and then you have electricity produced from the sugar. You have biofuel produced from the sugar cane again, and some other byproducts actually used for other things like cement additives and carbon burnout and construction of building industry. The Integrated Electricity Plan, 2003 to 2022, yes, that's an era. 2003 to 2012 actually had its vision to provide stable electricity for future support to socio-economic development. The latter one, which is projecting actually into the future, is to provide security, stability, and sensitive to environmental stability or imperatives. Two distinctions between these two strategic plans has been, first, it was just to ensure energy security. Now it's ensure energy security vis-a-vis the drive towards environmental imperatives. Cornerstone of the master plan have been, one, optimize the use of existing power systems, keep prices as low as possible, and for customers as well to participate in demand-side management of the energy sector. Right. Just an illustration of the land use change over the years. Mainly it used to be dominated by sugarcane. The island used to be dominated by sugarcane production. As you can see, the orange, that shows sugarcane production. This map shows for 1972. And then 1991, sugar is actually increased significantly. Almost the whole of the island is sugarcane. 2010, there is a distortion now. Actually, urban areas or built-up areas are increasing, and they're actually swallowing the land, or the land which used to be used for energy, for sugar generation. Look at the picture for 2013, latest, which actually shows more urban areas, and that depicts what I mentioned before, the issue of tourism actually superseding the sugar industry sector. And the main bearing to this has been the issue around declining prices in sugar, and hence most of the players in the sugar industry, they actually sell the land for tourism purposes. So you find hotels all over the island. Just to share with you electricity generation for Central Electricity Board and the independent power producers, where you have that 60 and 40% variation, which I mentioned. The next graph is just a projection of the energy generation into the future up to 2022, and again the sugar industry or the independent power producers actually playing a key or pivotal role in the energy supply of the country. Terragen is just an example of an independent power producer which is supplying energy to the grid of Mauritius, and mainly it's bagasse and coal, which they generate electricity from. And average bagasse exported into the grid is about 26.4% of the total annual energy which they generate in a year. Demand and proportion of generation by source. This is just to show the time series for the demand in the usage of electricity. And the key main sources or renewable generation is mainly hydro, Then there's solar, there's also wind, but biogas is the key contributor to the total percentage of electricity generation in the country. Evolution of electricity sales by customer categories. This one, maybe we can leave it for further discussion. I can see Prof. Nama is already standing up. But let me hasten to say the evolution of the fuel mix and the energy mix in the country is actually key. When you look at the energy consumed actually mainly from fuel and coal is much higher than those of the renewable energy sector, biogas and hydro. And the projection of this evolution actually up to 2014 shows that actually still much as there is room for renewable energy technologies picking up in the country, the role of fossil fuels, primarily coal, which is actually imported in the country, is still key for its development. Small silent observations and challenges revolve around the cost of renewable energy. Of course, the debate around the intermittent nature of renewable energy technologies. Hence, the Central Electricity Board for Mauritius actually doesn't put emphasis on it. Other aspects revolve around energy efficiency, which the customers or the consumers of the energy actually have to take into cognizance. In conclusion, Mauritius, like many developing and emerging economies, grapple with the challenge of attaining an effective energy mix. The island's massive infrastructure development promoting tourism is at the expense of the sugarcane production, which has got an ultimate bearing on energy generation from sugarcane or from biogas. And future projections based on business as usual scenario typify or show continued use of imported petroleum and fossil fuels more than the proliferation of the renewable energy technologies. Thank you.